All right, so let's go ahead and get this started. This topic is on high-performance Drupal. Basically, what we're going to cover in this session is all about the things that you can't do inside of the application. So these are all the tools that you can use to make sure that your Drupal site is as performant as it can possibly be, and scale up to thousands of users and be able to kind of perform without any downtime or performance degradation. So we'll start off with a little quick background about me. My name is Ben Routson. I'm the manager of professional services at Pantheon currently. Started out my career as a freelancer, self-taught. After I did that for about 5 years, I ended up getting a position at Acquia as a technical architect. During that time, since I started working for Acquia, I was able to have the opportunity to work with some very large customers. So NFL, Han, Wilson, very, very large enterprise organizations that require, 100% uptime. They require performance. They require global presence. So all of the things that enterprises need, I've been fortunate enough to be able to work with people at that level. So getting right into the meat of the presentation, on the professional services team at Pantheon, we deal with performance issues all the time. So basically, clients will come to us, either existing clients or new clients, and they'll say, how can I make my site more performant? How can I speed it up? And so we'll dig in, we'll start doing a performance deep dive or load testing or whatever the case may be to kind of start to analyze their performance and try to zero in on what the root cause is. From that experience, we've kind of come up with 3 things that are generally the biggest problem that you're going to run into. So the first one is, large and very complex database queries, which is obvious. External services tend to be a major bottleneck for Drupal sites. And then, especially for those enterprise brands that are global, we definitely see some performance degradation if they have a global audience and they're not solving for that, that single data center that's based in the US, but somebody's hitting it from a different country. So these are the 3 root causes that we're typically looking at. And so what I'm going to do today is go through some tools and some best practices on how you can actually improve your performance with those tools. So the first issue we talked about was the complex database queries. Drupal is an interesting tool. Almost every time where I've sat down with a new customer that's enterprise level customer that is evaluating Drupal for the first time, the first thing that they bring up is Drupal's database. They're like, that thing is massive and it's crazy and there's hundreds of tables in there. And so we have to kind of explain to them and talk them off the ledge that it's okay. We can make this perform. And so what I did was I took a little screenshot from the Umami installation profile that ships now with D8. And so one of the content types that it has is recipe. So you can see there's some custom fields there. I took a little shot of the coordinating database tables that are associated with those fields, so you can kind of get an idea of what's actually happening in the database every time you add a custom field. So it's just kind of multiplying out the database tables. So basically, websites need to be able to manage this complexity with all of those entity relationships without any performance degradation and without sacrificing user experience. I'm sure that, how many developers in the room right now? Drupal developers? Okay, that's what I figured. You're in the right place then. So, I'm sure you guys probably have worked with a design either a designer or a design company, and they've handed you a PSD or a design deliverable and said, go ahead and make this. And you look at it and you're like, that's like 14 different entities all combined into one object that I'm trying to present. How am I going to do that? And you start thinking about, okay, am I going to be doing entity relationships? How am I going to make this perform? How am I going to get all of these things intertwined together without it just kind of tanking and the website just crashing when somebody visits it? In addition to that, so that's kind of the field level. If you were to just go and install a Drupal 8 site, this is what you would get with the core installation. That's the database schema across a brand new Drupal 8 site. Absolutely insane. So yeah, pop quiz. Guess how many database tables are in the below scenario. So we've got one content type with revisions enabled and 10 custom fields. Anybody have any ideas how many database tables we'll end up with? How many? 22. Nice, exactly. 22 database tables for one content type with 10 custom fields. What if we add one entity reference and we have to load all of the fields associated with that entity reference? Now how many database tables are we pulling up? Any guesses? $12? 34 now, 12 plus 22, because we've got the original set of data tables, and then we've got an additional 12 on top of that. So you can see just by viewing one entity, you're able to pull out 34 database tables, and that's not including a whole bunch more that's actually happening on the back end as well. So this is a very major problem for performance, right? If you're constantly pulling up this many data tables, how possibly can your application be performant? And so this is kind of where we get our first tool that we're going to talk about. So Drupal's been doing it this way basically since it started. It's it's got a very large database, lots of tables. So we've got to figure out how we can work with it. The content editor portion of Drupal is so valuable that enterprise companies love it, small companies love it. So we just got to figure out a way to make this scale up to thousands of users and things like that. So one of the tools that I'm sure all of you have probably implemented at some point would be Solr or Elasticsearch, basically an indexing tool. One of the things that, and we'll get into some best practices there in a second. One of the things that is a common misconception, especially junior developers that come in and they start to learn about Solr, they think Solr is just for search results. And that's just flat out not true. It's an indexing tool. It allows you to kind of create a very static object and then rebuild that static object as many times as you want if that content gets updated. And so it works really well for this kind of database query issue that we're dealing with. So if you're going to start kind of presenting an entity that has 32 or 34 database tables in it, probably one thing that you might want to think about doing is getting the fully rendered entity and actually storing that into an index and then retrieving it, especially if you're going to be showing it in a list. So this is something that I've done quite a few times, especially with like product-based sites. I worked for a large furniture company that's based in the United States. It's like a $3.5 billion furniture company. And they adopted Drupal, which was awesome. And they kind of came across the same exact problem where they needed to be able to scale up their product catalog pages and things like that. So what we did was exactly this. We had their product catalog is all indexed inside of Solr. It can be ran asynchronously, and we can, based on their business rules, we can re-update the index as many times as we want and try to keep that as a static piece of content. Okay. The major thing that we see in terms of best practices that go awry with this type of architecture is you start off with good intentions. I'm going to use Solr to build this list out. But then when you get to the actual view portion of creating this kind of index view, you start to kind of branch off and grab fields from the database. You're basically grabbing the entity ID from Solr and then using that to actually do an entity load and pull in more fields, which entirely defeats the purpose of using Solr as an indexing tool. So I kind of put up a little screenshot of what you might see. This is this is Solr API. You can see when you go to add a field, there's an option for creating a new field that is a full rendered HTML output of a specific node. It can be any view mode, so it could be the full content view mode, the default, or any custom view modes that you create, and actually index that full HTML object into Solr so that you can retrieve the fully built, no database query required object and be able to serve that in your list. So yeah. Let's see. Yeah, so yeah, again, just make sure that when you're creating the view, don't add additional fields, use this actual HTML output field within your view to get full benefit from using Solr or Elasticsearch. All right, so the second problem that I listed up front was external services. So almost every website that I've seen in the last 2 years has some sort of a third-party service or API integration or something like that included with it. I've seen some sites who do a really good job of managing that request-response cycle to that API, and I've seen some that don't. And so what happens is you make this request, maybe you're getting a Twitter, or you're getting a tweet or something like that. You're making a direct API request to get that. When that comes back, chances are you're probably going to have to massage it a bit. You're going to have to change it. You might have to concatenate some strings together. There's a lot of work that goes into getting that data into a state where you can actually use it on the site. And so that's typically where we see our bottleneck is either it's a very expensive transform process where you're taking the data and you're transforming it and you're looping through it multiple times, and that becomes a very expensive process. Or the alternative, or the other thing that we see all the time is that that response is never cached. So every page load that you're looking at, you're hitting that API directly over and over and over again. And then it multiplies if you're making that external request at the entity level, where you're looking at a list. Now it's made 30 API requests without caching the response. So yeah, that's where the next tool comes in. So Redis and Memcache are the two most popular kind of object caching. It's similar to Solr in the way that it works. You basically do a key value store, and you can retrieve that key value however you want. I'm sure many people have probably already kind of implemented this to offload page cache. So in Drupal, page cache is typically stored in the database or in memory. And so Redis and Memcache allow you to kind of offload that page caching into Redis or Memcache instead of in the database, which eliminates a whole bunch of database queries that are unnecessary. So that's the normal implementation for Memcache and Redis. But for external service calls, what you can do is actually use Redis or Memcache to store the fully transformed response. So after you make the API request, you have it actually go through the transform process, and then you actually store the object in Redis, and then you can retrieve it from that point. I always say, use as much, have that be cached for as long as you possibly can, based on the business rules that are given to you. Any content owner, marketing person that's not technical is always going to think that they need real-time data, that they need it to come directly from the API every single time. And if you really start digging into that, you'll realize that generally that's not the case. They can cache it for 10 minutes or 15 minutes or whatever the case may be. And if you're on a high-traffic site, 10 or 15 minutes of caching that response is huge. That can be thousands of users, thousands of page requests that you've now served from cache as opposed to making a trip to an API and back. And then if you do have bulk data that you're grabbing from a REST API, best practice there would be to still continue to leverage object caching for that, but then also do some sort of batch API or have that data be kind of populated in cache in some kind of asynchronous way, either through a cron job or some other way. And then, of course, offload the page cache as well. All right, so the third major performance issue that we see quite often is clients that have a global presence or they've got traffic in other countries that they're targeting specifically, and their data center is in the United States. So what happens there is something called network latency. If, say, we're here in Minsk and you're making a request to a data center in Iowa, it's going to take a lot longer because it's got a long ways to travel through fiber and things like that before it can make it back and actually deliver the response. So one of the things that enterprise companies start to realize pretty quickly is that they need to have multiple points of presence to be able to kind of serve their site from. Which brings us to our next kind of tool. And before that, Another quiz. How long would a response take if you sent it across a fiber line that was stretched across the entire planet at the equator? Anybody have any idea? 300 milliseconds? 200 milliseconds. So that's pretty fast, right? That seems like it wouldn't be too much of an issue. You know, it's kind of it's more than what we want, but you know, it's kind of in an acceptable range. Problem is that that's actually like in an ideal scenario where it's a straight line of fiber and you're connecting two machines directly to each other. In reality, there's a lot of things that are happening well before it makes that long trip across the ocean. The ocean part is actually the easy part. That's the fast part. The part that's the slow part is that last mile when it hits that data center and then has to travel back to the, you know, through your local neighborhood of God knows what is installed, probably not fiber. And that's when you really start seeing major latency numbers. I know that we had a client that was based in Australia that we were serving from a Chicago data center, and it was adding on average somewhere between 400 to 600 milliseconds per request, which is half second. You know, that's a long time to give up just because of network latency. So how can we increase our points of presence globally? The answer is CDNs. We've got 3 listed here, Fastly, Akamai, Cloudflare. There's plenty more. There's a ton of CDNs out there that have multiple points of presence across the planet. So you sign up for one of these CDNs. Basically what happens is that you get to leverage their data centers. It will copy cache objects to each of the data centers as requests are made from that local area. And so subsequent users will get served that content from a local point of presence much faster than they would have if they hit the data center directly. The other thing that is a kind of nice bonus is that if you are leveraging a CDN for your entire site, like one of these 3, you can actually also have anonymous caching where it's not hitting your full stack, which is another huge enterprise solution to make sure that you can scale up to thousands of users. If you're on a CDN, you should have a very high hit cache ratio as long as you've set up your headers and things correctly. And you should be able to serve thousands of sites without running into major issues, and also serving them at that local data center. Okay, so a couple more things to kind of talk about. That when you start talking about caching and you start talking about storing things in Redis and indexing and things like that, you start to come up with ways of like, how can, if as a content editor, how can I make sure that I'm getting the most fresh content when I hit save? And there's a lot of different ways that you can handle cache invalidation. Drupal 8 actually brought a very kind of like robust solution for cache invalidation. How many people in here have used cache tags on D8? Okay. So cache tags, basically what it is, it just adds kind of a comma delimited set of strings to the surrogate key header in your response object. And based on what's in that surrogate key header, if you go, say maybe you go and change a block, there's a block ID in that surrogate key header that's listed as a cache tag. Anywhere that that block appears across your entire site, that cache gets invalidated when it gets updated, which is great. You know, so right now we've got a very intelligent way to kind of invalidate cache. The problem with this that we see pretty often, and kind of something that you need to think about when you're thinking about your cache invalidation strategy, is that depending on how your site is architected, you can blow away your entire cache pretty easily. Say if you've got a block that's on every single page of your site, and you go and you edit it, then all of a sudden you've just invalidated your entire site's cache. So if you do that during a peak traffic moment, that can have major impacts on performance. It may even cause downtime on your site with a flood of traffic all of a sudden is bypassing CDN and coming straight into your site, full stack request. One more thing that I didn't bring up in the beginning part, but I think it's also kind of important to note, is that high performance Drupal sites do a really good job of separating their concerns. So what I mean by that is you have a separate application server, you have a separate database server, you have a separate file storage, If you separate all those three things out, you're really taking a lot of workload off of your application server, which is going to speed your site up. And so I highly recommend always thinking about decoupling your architecture from each kind of instance there. On the file storage side of things too, so separating your concerns does many things for you. Performance is one. Having more uptime is another. The other thing that's really great about it is that it makes it a lot easier for you to migrate platforms if you need to. So like say, today you're on Acquia and you decide that you want to migrate to Pantheon. And you quickly realize that now I've got to migrate 500 gigabytes of files, that are stored on Acquia. Well, if you had those 500 gigabytes of files stored on Amazon, on S3, then you could just migrate your site over and you wouldn't have to deal with moving 500 gigabytes of files, right? And so that's kind of the philosophy behind it. It makes your application not be tied down to a specific hosting platform or server. You can move it around if you need to. It also allows you to horizontally scale a lot easier if you want to set up your own kind of horizontally scaling server architecture. So separating your concerns is definitely like a major part of having a high performance Drupal site. Okay, so this whole time you thought you were at a session. Turns out you're at a sales pitch. So how can I manage all of these tools? So you've got a couple of options, right? You can stand up AWS EC2 instances or Compute Engine instances on Google and Google Cloud and all of these things, or you can just go and find a platform that actually does all of these things for you. And so I've listed a few up there. So, having said all of that, what kind of questions do you guys have around performance and building high-performance Drupal sites?
Hi, thank you for your speech at first. Have you ever had a case with China, a country, when you talked about the cloud services? Well, it's not working like that with China, and do you have any suggestions except the case when you put server directly in China?
Yeah, so you're talking about CDN specifically, right?
Yeah.
Yeah. So Cloudflare actually has points of presence in China. Fastly does not. I think I'd imagine Akamai probably does. So if I back up to that slide, the second bullet that I put there that I didn't read out loud is use a CDN with points of presence that are in your area. So if Fastly doesn't have a point of presence in the area that you want to serve from, then that's probably not the right CDN provider for you. So then you go and research which ones do, and then you select the right one based on where you need that traffic to be served from.
Hello. Thank you for your speech. I have a question about Drupal block caching. You said about Akamai CDN, and as I remember, Akamai CDN provide one of the advantages of using Akamai is ESI language, which allow us to cache blocks on the page. So is it possible to store Drupal blocks in Akamai instead of a database cache or Redis?
You're talking about like error logging and access logs and things like that?
No, I'm talking about block caching.
Block caching?
Right.
Oh, gotcha. Yeah, so that's actually wouldn't go into your CDN. That would go into Redis or Memcache. But yeah, basically, there's configuration that you can put into your settings.php file to offload the cache bin from the database to wherever it is that you want to go. So it's just like a couple of lines in your settings.php file to be able to kind of offload block cache.
You can find answer on this question in my presentation.
Shameless plug.
Ben, thank you a lot for your speech.
Yeah.
I have a question about Solar. I always think that, so I use Solr mainly for the full text search. And when I get this, I get the entity type and the entity ID, and I load the entity from the database.
Yeah.
So you suggest to use HTML response from Solr
Yes.
rather than use, do you have numbers? So do you have any?
In terms of benchmarks, I don't know any benchmarks off the top of my head, but you can imagine what that looks like, right? So if you think about that from a high level, so you've made a request to a Solr server. The Solr server turns back an entity ID, and then you go back to the database to pull those fields from the database, and now you're back to the 32 database tables that you've had to join and have this massive complex query in order to get that data back. So you've kind of why not just make the database query and bypass Solr altogether? Because all you're getting from Solr at that point is just an entity ID.
But you just get the HTML code and you don't have any process and other stuff you can influence on it, as I understand. So
right, so that's why you want to make sure, so backing up a little bit on that, it's a good question. So what you want to do is make sure you're architecting your site in a way that sets you up to be able to do that. So like, building out a custom view mode for whatever list it is that you want that content to be returned in. Inside of that view mode, you set up that HTML exactly the way that you want it. So that's where you make all of your adjustments, is inside of the view mode, right? And then you index that view mode, and now you know that it's coming the way that you want. And instead of coming from the database from 32 or 34 database tables, it's coming from a single request to Solr. It's going to be much, much faster.
But if we use multilingual website, so
yep.
what we do?
So, and this is probably treading into his session territory, but I'll answer it. You can index multiple fields. And when you say fields, when it comes to Solr, it's not Drupal fields. It's just kind of data that you store along with that full object. So one of those fields essentially is language. And so when you pull that back in, you'll have access to not only the HTML output, but you'll also have access to the language in your view, and you'll be able to kind of filter out based on language from that one field. Does that make sense? And that field is coming from Solr, not from the database.
Okay, thank you.
Yep. Really good questions.
Thank you for your speech. One more question. If we use Search API with Search API Solr,
okay,
are you completely sure that Search API, and we use views for that, are you sure that views don't load the entities from the database, even though the response is received from Solr?
Yeah, so there's a specific view type that you have to create. So once you enable Search API, it creates a new view type for the index, and that's how you know for sure that it's making the request to Solr.
So you're sure that it
Yes.
doesn't make a request to the database again?
Very sure, yep.
I see, okay, I'll double check, thank you. And just one note, if we use Redis or Memcache on the site, the difference between storing the rendered things in Solr and not storing them there would be not so much, not so big, since we get the things from Redis, right?
Right, yeah. So I mean, you start to architect out a full solution, right? There's also, so one of the things that I didn't mention is that you can also end up with a very interesting caching situation where you don't really know where things are being cached. So for instance, if you've got global CDN in front of your view, and your view is returned from Solr, but then CDN is caching that Solr view and then serving it up. So now you've got two layers. You've got your index, you've got your CDN version, and so now it makes troubleshooting a little bit difficult to do that. So usually what I recommend is that if you have a view that you want to control via Solr, probably bypass CDN for that. So that you're, especially if it's like a situation where you are have like custom filters and things like that, where you need to kind of return those values, and you want it to be very, very quick and be able to reindex with content and not have to deal with blowing away cache to do it. That's a good approach to keep it simple.
I see. And another question regarding Pantheon itself, not regarding your speech. Pantheon hosting is only in USA, right?
Well, so as of recently, we actually have a EU data center that we've rolled out, so you can actually get.
Where is it?
Where is that? Do you know where that's at? The EU data center? No, I think it's Germany, to be honest.
I see.
Yeah.
Okay, thank you.
Amsterdam?
It should be behind the corner. Here in Minsk.
I'm sorry?
Your data center in Europe should be in Minsk.
Exactly. I'll get on that.
Guys, any questions?
Awesome. Thank you guys for listening to me talk for 45 minutes.